Section 15D, question number 1, page 371. Question 1 asks us to use the quotient rule to find dy by dx given the following functions. Well, just before we get started on that, suppose y is f of x divided by g of x. It's a rational function. Then dy by dx is the derivative of the top, f prime of x, multiplied by the function in the denominator, minus the function in the numerator multiplied by the derivative of the function in the denominator, all over the function in the denominator squared. Okay, so we're going to use that form to find the derivatives here, or the gradient functions. Okay, so part A, y equals 1 plus 3x all over 2 minus x. So we'll use the quotient rule. So we'll take the derivative here. So the derivative of the top is 3, and we multiply that by the function in the denominator. And then we subtract the top multiplied by the derivative of the bottom, which is -1 in this case. And that's all over the bottom squared. It's very important that we take the derivative of the top first and then multiply by the bottom, and then leave the top and multiply by the derivative of the bottom. The reason being is because of the subtraction sign. If we do it in the opposite order, then the signs get mixed up. Okay, so it was okay with the product rule to do it in whichever order you like, because we had the plus sign in the middle, and the order didn't really matter in that case because the signs wouldn't change, whereas here it does, or the order does matter, because that subtraction sign will change the signs of the second function. Okay, so you have to make sure that you do the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom in order to get the signs to work out correctly. Okay, so now that I've given that little warning, now we're going to just expand out the brackets in the numerator and then do some simplifying. So I'll multiply this in, so we get 6 minus 3x, and I'll multiply the -1 times this negative, and then multiply that in, so we end up getting +1 plus 3x all over 2 minus x squared. Generally I would leave this because if we need to do this for curve sketching in the future, then it's easier to use this denominator in factored form in order to find the positions of any vertical asymptotes or any other sort of feature that we might need. So -3x plus 3x becomes 0, 6 plus 1 becomes 7, so dy by dx equals 7 over 2 minus x all squared. Part B, the function is y equals x squared all over 2x plus 1. Now we're going to take the derivative by using the quotient rule. So the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom all over the bottom squared. Now I'll just do a little bit of expanding and simplifying here. So I get 4x squared plus 2x minus 2x squared all over 2x plus 1 all squared. And then I can simplify up top here. So 4x squared minus 2x squared gives me 2x squared plus 2x over 2x plus 1 all squared. And then I can factor out a 2x from the top here to give me 2x quantity x plus 1 all over 2x plus 1 all squared. Question C, y equals x over x squared minus 3. So I take the derivative of this using the quotient rule again. Derivative of the numerator is 1 multiplied by the denominator minus the numerator multiplied by the derivative of the denominator all over the denominator squared. Again, I'll do some simplification. X squared minus 3 minus 2x squared all over x squared minus 3 all squared. So then 2x squared minus x squared is going to be negative x squared minus 3 all over x squared minus 3 all squared. And then what I can do is I can factor this negative out and just put it in front of the bracket. So I have negative x squared plus 3 all over x squared minus 3 all squared. Okay, so now I'm going to move on to question D. And we've got y equals root x over 1 minus 2x. I'll change the form of this root x into exponent form, so I have x to the 1/2 all over 1 minus 2x. And now I'll use the quotient rule again, so dy by dx. Derivative of the top is 1/2 x to the negative 1/2 multiplied by the bottom minus the top again multiplied by the derivative of the bottom all over the bottom squared. So that's all the calculus part. Now we're just going to get into some simplification. So I'll leave this for now, 1/2 x to the negative 1/2 multiplied by 1 minus 2x. Multiply these two together to give me plus 2 root x. I'll change that x to the 1/2 into a root x. And leave the denominator as it is. And then what I'll do is I'll change this also back into square root notation. And because it's negative, we'll drop that into the denominator, and that 2 will also drop down. So we end up getting 1 minus 2x plus 2 root x all over 2 root x quantity 1 minus 2x all squared. Now in part E, y equals x squared minus 3 all over 3x minus x squared. And I can just go ahead and apply the quotient rule here. So the derivative of the top is 2x multiplied by the bottom, subtract x squared minus 3, which is the top again, now multiplied by the derivative of the bottom, which is 3 minus 2x, all over 3x minus x squared, all squared. Now I suppose what I could do is I could expand all this in and simplify, but in this case I think I'll just leave it like that, because we're not really going to be doing anything else with that eventually anyways, so I'll just leave it as it is and focus my attention on part F, where the function is x over the root of 1 minus 3x. I'll change that to x over 1 minus 3x all to the power 1/2. And then I will again use the quotient rule as instructed. The derivative of the top is 1 multiplied by the bottom, subtract the top multiplied by the derivative of the bottom, and here I'll use the chain rule so the 1/2 comes down in front. Leave the inside as it is, subtract 1 from the 1/2 to get negative 1/2, and then take the derivative of the inside, which is negative 3, and that is all over 1 minus 3x to the 1/2 squared. So there's going to be a little bit of simplification that we can do here. So maybe write that as, will I write that in square root form? Not yet, I'll leave that for now. So 1 minus 3x to the 1/2. Now here we've got -3 and a 1/2 and a negative x out here, or minus x. So I'll bring all this stuff out together, so I'm going to have plus 3/2 x, 1 minus 3x to the negative 1/2, all over, and then this denominator, the 1/2 and the 2, can come together to have a little party, so we get 1 minus 3x. So then what I'll do is I can now, in this next line, bring this part down into the denominator, because that's the no, sorry, you know what, I can't do that unless I factor that out. Maybe I'll do that. Yes, I will do that. I'll factor this out, so I get 1 minus 3x to the negative 1/2 multiplied by 1 minus 3x plus 3/2 x all over 1 minus 3x. Now I'll bring it down into the denominator and simplify this up here, so I have 1, and this would be 6 over 2x, so it would be minus 3/2 x all over 1 minus 3x multiplied by 1 minus 3x to the power 1/2, so it would be 1 minus 3x to the power 3/2. And if I want to return that to root form as it is given in the question, I'll then change that to 1 minus 3 over 2x over the square root of 1 minus 3x cubed. And that would be the derivative of the given function for part f.